Hi students, good evening. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss your Module 6 homework. Please, before you continue with this video, it is recommended that you have read the notes, read your textbook, and viewed the videos as well, the prerequisite videos on correlation and regression. So this is your Module 6 homework assignment here. But let's get on my website. We have done this, most of the questions in this Module 6 assignment. We have done it we did that in Math 130. Math 130 is applied finite mathematics. Let's get on my site for a moment. The mobile friendly one. So you click on mathematics, statistics, and the notes here. If you click on notes here, the notes, you would see the Module 4 homework study guide. I understand this is for applied finite mathematics, but it covers most of the questions we are going to do in this video. So it is recommended you have looked at this too, for the notes, for the explanations, for the notes. Then in this video, as usual, we are going to use my calculator. If you click on resources, correlation and regression calculator. Correlation and regression calculator. And then Statcrunch. We're going to use Statcrunch just for the scatter diagrams. Because why? Most of the questions we used Statcrunch in this video to kind of save time. Okay, if you click on here videos, you go to actually it's gonna be under finite math, and under the videos you go to module homework and exam study guide for Math 130 applied finite mathematics. So in this video right here, we use Statcrunch to solve the problems, okay? Because most of the questions in this topic have already been covered in applied finite mathematics under Math 130. Most of the questions in this topic on statistics, it has already been covered. So if you want to know how to use Statcrunch to solve most of these questions, then please view this video to avoid, to save time and to avoid repetition. So this video we use Statcrunch to solve most of the problems. That's in this particular video right here under applied finite math. And of course the notes, you can still get the notes under finite math, the notes. And that is Module 4 homework study guide. These are the notes right here. So, but this particular video, we're going to use my calculator. And we shall also use Statcrunch just for the scatter diagrams. Okay, we shall use Statcrunch just for the scatter diagrams. Okay, let's begin. So, question 1, determine whether the scatter diagram indicates that a linear relation may exist between the two variables If the relation is linear, determine whether it indicates a positive or negative association between the variables. Use this information to answer the following. So, like I said, okay, this is covered. Let me get on the notes. This is on the notes. Module 4 Homework Study Guide. So, like this first question right here, I'll show you the answer right away. It was done in Math 130, Applied Finite Math. So, you see, this is the first question right here. As you can see, that's the first question. So, if you look at this here, you see it's non-linear. You look at this, you see it's non-linear. See, this is non-linear relationship. This is positive linear. This is negative linear. So it will be good if you have reviewed all these. This is the notes, and of course the video is right here. The video for the explanations. So just to save time, you know. So this is non-linear. You look at the options. This non-linear because they do not lie mainly in a straight line. Okay. If you look at the notes here, that was the reason. Non-linear because they do not lie mainly in a straight line. Do you see that? Okay, so it's non-linear because the data points do not have a linear relationship because they do not lie mainly in a straight line. That's it. If the relationship is linear, do the variables have a positive or negative association? So here the relationship is not linear. Okay? It's not linear. Question 2. Determine whether the scatter diagram indicates that a linear relation may exist between the two variables. So it's still the same thing here. See that? Still the same thing here. This one is linear because the points lie on a straight line, lie mainly in a straight line. Okay? And this is negative, as you can see, it's negative. Your negative slope, okay? This represents negative slope, has a negative association. So please, this is the note right here. This is the notes here. And of course, the video of the explanation is right here. Okay. And that is from Applied Finite Mathematics, Math 130, Applied Finite Mathematics. Later, you can view this. Question 3, for the accompanying data set, draw a scatter diagram of the data, compute the correlation coefficient, and determine whether there is a linear relation between x and y. So let's draw the scatter diagram, and all this also we did it in Math 130. Okay, like I said, we are just in this video we will just use Statcrunch to do scatter diagrams, and then my calculator we will use it to solve the rest of the questions as applicable. So to draw a scatter diagram, click the icon to view the data set. And then right here at this, click to copy table, click on it, open in Statcrunch. Open it in Statcrunch. And then you go to graph. Under graph, you click Scatterplot. Scatterplot. For the x variable, select x. For the y variable, select y. And just click compute. Click compute. Now, let's kind of observe this. Let's see this. I'm gonna close this right here and pull this. let's see this side by side. Okay, so we can compare. So look at this here. You will see that A is out of the question. A is not it. Process of elimination. A is not it. And this is just like your normal graph. Okay, it's just like your normal graph actually. So A is A is out of the question. The first one should be 6. X is 6, Y is 6. So process of elimination. Actually, I'm sorry. With the first one, don't eliminate A yet, okay? Because if you expand this, if you expand the graphs to kind of say it, 1, 2, 3, 4, 5, 6. So 6, the first one, and then Y, 1, 2, 3, 4, 5, 6. So first of all, let's see who to eliminate, and then we will now know what graph right away. The second one, the first point is 6, 6. Okay, that's the first point. If you point your mouse at this, it shows it to you 6, 6. Or even if you click on the icon to view the graph, you see it. You will still see 6, 6 here. Okay. So you want to make sure, just like when they drew this graph, you see here that this first one is 6 and 6. So here is not it. So B is out. A is not out, but B is out. Okay. B is out. And you see the points does not look like B. You look at C. C is out because the points does not look like C. Okay, look at how these points are. And then you look at D. D is out also because it doesn't look like D. You can now, if you want, you could just look at these data points, and then you expand these graphs to check it, to check the points. Like this is 6 and 6. This one is 6 and 7. Okay. This here is 6 and 6. This one is 6 and 7. When X is 6, Y is 7. And if you look at the graph, you see when X is 6, Y is 7. And that will be this point. Okay. But to save time, you know, these videos are just using technology right away. So after you have read the prerequisites and viewed the prerequisites videos, then we want to just use technology and just solve the problems. So as you can see here, B, C, and D are eliminated, and the correct option now is A. Okay. Compute the correlation coefficient. So this is what we're going to do here. I'm going to close this. I'm going to open up my calculator. Okay, you can use first formula or second formula, it doesn't matter. Let's look at this calculator for a moment. If you scroll down here on these resources, we have two formulas. First formula for calculating the correlation coefficient, excuse me, and then second formula for calculating correlation coefficient. Both formulas will give you the same answer. Now, you might ask me, why the need for two formulas? What is the difference? Well, the first formula, you have to calculate the mean and standard deviation. And the second formula, you do not have to calculate the mean and standard deviation. If you look at the two formulas, you will see what I'm talking about. So we can use either one. Okay, we can start with first, it doesn't matter. So I click on first formula. To get to any link you want really fast, it's good you get to resources and click on that link to get to it real fast. So I'm gonna restore this, and then let's just do this side by side so you see it. Here it says type your X values, separate each value with a comma. do not put a period at the end. Also, do not put a comma at the end, okay? So I put 7, comma, okay, and you can put space. If you like, you put 7, you put a comma. You can put space, or if you like, you put space before you type in the next number. If you like, do not put space. It doesn't matter, okay? 7, 6, 6, 7, 9. Okay, please do not put a period at the end, and do not put comma at the end. The same thing goes for y values. 8, 7, 6, 9, 5. So when you finished with this, all you need, now I wrote all these, so if you need to let me make this bigger. If you're doing this by hand, this would help you to find out any step you missed, okay? This is showing all steps. So this calculator really helps you. If you're solving it by hand, if you look at the notes, you will see I solved it by hand. Then you need to show all your work, and sometimes students make mistake in a particular table or a particular step, and that would affect the result. But with this table, it tells you, so you just scroll down, click calculate. Okay, when you click calculate, you see all these are the values, so that if you make any mistake in any step, you can easily spot it out. These are the values as is, without rounding it. So it's up to you to now round it. Okay, you can now round it. So we see here the correlation coefficient is this here. So compute the correlation coefficient, round to 3 decimal places. So the correlation coefficient is negative 0.387. Okay, and that's it. And then that is the nice thing about this calculator. It gives you all the details. Okay, it shows you the steps, show all steps, gives you the least squares regression line as applicable. Least squares regression line is the same thing as line of best fit. Tells you the residuals and other details as applicable. Of course, this is the residual here. Observed y minus predicted y. This is the residual. This is the square of the residuals. Okay, this is the square of the residuals here. I'm sorry, this is the residual right here. Observed y minus predicted y. This is the residual, and these are the residuals. These are the square of the residuals, and this is the sum of the squared residuals right here. So it tells you almost everything you need to know to solve these questions. So the correlation coefficient is negative, as you can see. The correlation coefficient is negative. Absolute value of the correlation coefficient is positive. Absolute value is positive. So because the correlation coefficient is negative, and the absolute value of the correlation coefficient, the absolute value of the correlation coefficient is 0.387, and it is less than the critical value, not greater than the critical value for this data set. The critical value for the data set for sample size 5 is 0.878. Therefore, no relation exists. Okay, no relation exists between x and y. Okay. So that is that. Let me kind of close all this and have only this open. Question 4. A pediatrician wants to determine the relation that may exist between a child's height and head circumference She randomly selects 8 children, measures their height and head circumference, and obtains the data shown in the table. Okay? This is a table of critical values. That's fine. A, if the pediatrician wants to use height to predict head circumference, determine which variable is the explanatory variable and which is the response variable. So, explanatory variable is your x variable. And then your response variable is your y variable. So you use your x to predict your y. Okay, you use your x to predict your y. You're using the height. You want to use the height to predict she wants to use the height to predict head circumference. So x is the explanatory variable, and that is the height. Y is the response variable, and that is the head circumference. You use your x to predict your y. Okay? You use the number of burgers you ate, the number of cheeseburgers you ate, to predict your weight. Remember the example I gave about that I have increased in weight because of the McDonald's cheeseburger. Okay, so so the explanatory variable is the height, response variable is the head circumference. Yeah, and that is it. And then also, whenever that's the basic explanation. Now, whenever you see tables like this, on a side note, whenever you see tables like this, x usually comes first and y comes second. Yeah, but for this question, just look at the question. Okay, and that is the answer. Draw a scatter diagram. So let's click right here, open a Statcrunch. And we go to graph, Scatterplot. Get the x is the height, okay, and y is the head circumference, and click compute. So let's look at this side by side and see the Scatterplot. Let's see the Scatterplot. So which one? Let's see which ones to eliminate and which ones we shall concentrate on. So if you look at this, the way it is, this B will be eliminated. We're going to eliminate B because it doesn't look like this. Just compare this Scatterplot with this. Okay, B doesn't look like this Scatterplot. So eliminate B. And eliminate C. Eliminate C as well. So we're going to look at A and D. A and D is what we are left with. That looks like this. Look at the points. But you check here, the height should be your x and the head circumference should be your y. In D, height is the y. So we eliminate D. So we are now left with only A. Okay? Compute the linear correlation coefficient. All right. So here, let's get on my site. We can use the second formula this time around. It doesn't matter. You can use first formula or second formula. It doesn't matter. So this is 27.25, 25.75, 26, 25.5, 27.75, 26.5, 26.25, and 26.75. Count it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. When you are typing this, please make sure your decimals, that you don't skip the decimals. Okay? Depending on the computer you use, or depending on how hard you hit the decimal point. Just type it in well to get the correct answer. Now for your y, 17.2, 17, comma, 17.2, comma, 17, comma. I put, after my comma, I put space before I type in the next number. And it's just your preference. It doesn't matter whether you put space or not. Then we have 17.5, 17.4, 17.2, 17.3. 1, 2, 3, 4, 5, 6, 7, 8. All right. 8 patients. Click calculate. There you go. So compute the linear correlation coefficient and round to 3 decimal places. So this will be 0.8099 will be 810. 0.810. 0.810. Okay. Then it says, does a linear relation exist between height and head circumference? Yes. Therefore, there is a positive linear relation. Yes. Because R is positive and R is greater than the critical value. If you read this here, you will see what I'm talking about. R is positive. R is greater than the critical value. So there exists a positive linear relation. Okay, and that is C. All right. Question 5. Later you can look at the instructor tip. Excuse me. Researchers wondered whether the size of a person's brain was related to the individual's mental capacity. They selected a sample of 3 females and 3 males and measured their MRI counts and IQ scores. The data is reported on the right. Well, I see the data on the left. Okay, so treat the MRI count as the explanatory variable. That's your X. Compute the linear correlation coefficient between MRI count and IQ scores for both the males and the females. Do you believe that MRI count and IQ scores are linearly related? So let's use my calculator. The first one was for females. So let's click on reset. You can reset this to start afresh. When you reset, I know these answers don't go away, but don't worry about it. Okay? These answers will later go away. Like it will change when we click calculate after we put in the new information. So just when you click on reset, it changes the whole, you have a new data set to type into. A new data set forms to type into. Okay. First formula, females, 856473, comma. Please don't put 856, comma, 473. Please, no. If you put it the way they put it, you will get a wrong answer. Okay. Just put 856473, comma, space, 991305, and 857781. This is the MRI is the explanatory variable, and that is our X. Then the Y, we have 141, 138, and 135. And these are for the females. for the females. Okay, click calculate. So you click calculate. The linear correlation for the females will be 3 decimal places to 3 decimal places will be negative 0.008. Okay. Then we need for the males. For these males, let's use the second formula. I'm gonna reset this. Click reset. Second formula for the males: 924,060 1038,438 965,355. Then for the Y, 138, 138, and 132. Calculate. Okay, 924,060 1038,438 965,355 138, 138, 132. All right, correlation coefficient here we have 0.158 to 3 significant figures, to 3 decimal places, Okay, that's it. MRI count and IQ linearly related. So let's go back to the females. Here, for the females, there is no relationship, no. So the linear correlation coefficient for females is close to 0. It's not close to -1, it's close to 0. So no relation exists. And for the males, let's look at the males. No relation exists for the males as well. Linear correlation coefficient is close to 0, so no relation exists for the males. Okay? Comprendez? Comprenez-vous? Do you understand it? Question 6. For the data set below, determine the least squares regression line. B, graph the least squares regression line on the scatter diagram. So we can go ahead. Let's use first. We can use first formula or second formula. It doesn't matter. Just click reset here, and we type in this. X is 4, 5, 6, 7, 9. So when they ask us to find least squares regression line, so we know that a relationship exists because the least squares regression line, we can use it to predict the response variable that for which the explanatory variable falls within the data set that they gave us. So whenever we are asked to find least squares regression line, most often that means there's a relationship that exists between the variables. X, we have 4, 5, 6, 7, 9. Y, 3, 5, 4, 8, 11. And actually, that is what least squares regression line is useful for predicting Y for some value of X, provided a relationship exists. So, for least squares regression line, there's a relationship that exists between the variables. So you put in this for X, data X and data Y. Click calculate. And this is our least squares regression line right here. Okay, Y hat equal to this mx plus b, slope times the x plus your y-intercept. Your mama ex-boyfriend, y equal to mx plus b. Okay, your mama ex-boyfriend. Something you did in probably middle school. Okay. Excuse me. Okay, let's go ahead and type this. Round to 4, equation of a straight line. Y equal to mx plus b, right? Your mama ex-boyfriend, right? Excuse me. Okay. Round to 4 decimal places as needed. So this is 1.6081. Okay, round to 4 decimal places. 1.6081. As needed. As needed, meaning if it is greater than 4 decimal places, you make it 4 decimal places. If it is not up to 4 decimal places, then you write as is. Okay? Or if you want, you can still make it up to 4 decimal places. Or you write as is. That is what as needed means. If it is greater than 4 decimal places, make it 4 decimal places. If it is not greater than 4 decimal places, write the answer as is. Okay, if it is 1 decimal place, write only 1 decimal place. As is. Okay, or if you want, you can still make it up to 4 decimal places by adding zeros as appropriate. Okay, so that's our slope, 1.6081. And the y-intercept will be negative 3.7703. Okay? That's it for least squares regression line. Now they want us to draw this scatter diagram. So I'm gonna let's go ahead, click on this, open in Statcrunch. Graph, Scatterplot. X, select your X variable X, Y variable is your Y. Compute. So let's see which one resembles that, what we can eliminate. Okay, which one looks like this? We eliminate B. B doesn't look like it at all. B is like all the points lie on the straight line. You see that? That's B. We eliminate B, we eliminate D. D, all the points lie on the straight line. We eliminate B, we eliminate D. You look at this B and D, the residual is 0, the residual for B and D. Now, for A and C is what we are now going to look at, which one looks like that. And if we look at it carefully, we see that we will have to eliminate C, okay? And it really looks like A. Question 7. For the data set below, A, determine the least squares regression line. B, compute the sum of the squared residuals for the least squares regression line. So, I'm going to close this and pull up my calculator. We can go ahead and use the second formula, but let's reset it. Reset. X, we have 10, 20, 30, 40, 50. Y, we have 132, 115, 106, 92, 77. And we click calculate. So the least squares regression line we have here, this here, will be negative 1.33 times X plus 144.3. It says round to 4 decimal places as needed. And this, the answers do not, the slope is 2 decimal places, and the y-intercept is 1 decimal place. So it's this as needed. We can just write it like this, okay? And then some of the squared residuals. Okay, so this is the residual here. Observed y minus predicted y. These are the residuals here. These are the square of the residuals if you are showing your work. And I did it on the notes. If you go back to Module 4 Homework Study Guide for Applied Finite Mathematics, you see I showed my work by tables showing all your work. So if you do that, you will get these answers here. And the sum of the squared residuals is this right here. Okay, that is this right here. This is the residual. These are the squared residuals, and these are sum of sigma means summation. Sum of the squared residuals. So round to 2 decimal places as needed. So this is just 12.30. That's it. Okay. Question 8. A student at a junior college conducted a survey of 20 randomly selected full-time students to determine the relation between the number of hours of video game playing each week, which is your X, and grade point average, which is your Y. She found that a linear relation exists between the two variables. The least squares regression line that describes this relation, I am not surprised that the slope is negative. I'm not at all. Because if you play video games, that means you're not studying. Hey, that means you're not studying, right? And that would affect your GPA. So I'm not surprised that the slope is negative at all. I'm not. So this is the least squares regression line right here. Okay. A, predict the grade point average of a student who plays video games 8 hours per week. So all you need to do, you can use your calculator. Just do negative 0.0581 times 8 plus 2.9247. That's all you need to do, and you will get the answer. Okay, but I'm still gonna use my calculator to do this. In my calculator, just if you go under resources here, look for predicted y and residual. Predicted y and residual. So I'm gonna do this, but you can use your calculator to just do it. That is the nice thing of least squares regression line. Once you find there is a relationship between the variables, you can then calculate your least squares regression line, and you can use it to predict your y for any x within the range of the data set x that was initially given to you. Okay, so I'm gonna put in this here, negative 0.0581 x plus 2.9247. And they want us to predict for 8 hours. Predict your y for when x is 8. When x is 8. Predict the y. Okay. And of course, when you click calculate, it says please fill out this field. Because I want it I initially did this for residual. Okay. I initially did it for residual. And that's fine. We don't know there's no observed y. Okay, they're asking us for predicted y. Okay, so we can just put the observed y as 0. It doesn't matter. It doesn't matter at all. Predicted y is what we need. Okay, and nearest 100th round to the nearest hundredth means 2 decimal places. So this will be 2.46. That will be the GPA. So this actually means, because this interpretation of the least squares regression line, if you interpret the least squares regression line, this means that for each additional hour, this is the slope, negative 0.0581. So the interpretation means that for each additional hour that a student spends playing video games in a week, the grade point average, of course, because it's a negative slope, it will decrease. Okay, it will decrease because it's a negative slope. It will decrease by negative 0. Well, you said decrease, so there's no need to put negative again. So that would be 0.0581. It will decrease by 0.0581 points on average. Right? Y-intercept. Interpret the y-intercept. Y-intercept is when x is 0. When x is 0, what is your y? So that is the interpretation of the y-intercept when x is 0. So, and your y-intercept is this. Remember, this is y equal to mx plus b. Okay, the equation of a straight line. M is the slope, b is the y-intercept. Right? Your mama ex-boyfriend. So y-intercept is when x is 0. What is your y? So the average number of video games played in a week by students is this. That is wrong. The grade point average of a student who does not play video games, when x is 0, is 2.9247. So somebody who doesn't play video games, that's the y-intercept, will be 2.9247. Okay. Now, a student who plays question D. A student who plays video games 7 hours per week has a grade point average of 2.41. Is the student's grade point average above or below average among all students who play video games 7 hours per week? With this first, you can, when x is 7, find your predicted y, and you can use it to compare this question. But I'm going to use my calculator. I just put x to be 7 here, and I press calculate. So as you can see here, the student's grade point average, and that is one of the nice things about residuals. Okay, when the student plays for 7 hours, you will see that the GPA will be 2.518. That's the predicted GPA. But this particular student played for 7 hours and has a grade point, a GPA of 2.41. So as you can see, the residual is negative. Residual means observed y minus predicted y. Okay, this is what the student is predicted to have for if the student plays 7 hours of video games. But then the student has a lower than that. So that means the residual is negative. Residual means observed y minus predicted y. So because of that, it is below average for people who play 7 hours, okay, per week. So it is actually below average. Below average, okay? Question 9. We are getting there. You can review the instructor tips later on. An author of a book discusses how statistics can be used to judge both a baseball player's potential and a team's ability to win games. One aspect of this analysis is that a team's on-base percentage is the best predictor of winning percentage. So on-base percentage is the best predictor of winning percentage. So that kind of tells you on-base is the X and winning percentage is your Y. So the on-base percentage is the proportion of time a player reaches a base. For example, an on-base percentage of 0.3 would mean that the player safely reaches bases 3 times out of 10 on average. For a certain baseball season, winning percentage Y and on-base percentage X are linearly related by the least squares regression equation. This is the least squares regression equation right here. Okay. Complete paths A through D. So the slope is 2.94 and the y-intercept is negative 0.4877. Interpret the slope. So the slope, the winning percentage is the y. It will increase by 2.94 percentage points on average. So the winning percent, so B and C, you eliminate it. You look at A and D. Okay. And you look at D, the winning percentage will increase. That's right. So it's going to be D. The Y is going to be the one that will increase. Okay. Because the X is used to predict the Y. For this baseball season, the lowest on-base percentage was 0.310 and the highest on-base percentage was 0.362. Does it make sense to interpret the y-intercept? Remember, the y-intercept is when the x is 0. When x is 0, that is when you find the y-intercept. Okay. So 0, you look at this, you use least squares regression equation to predict, when you look at the x and y, find out whether they are really related. If they are related, find the least squares regression equation. Okay, and then you use it to predict for values of, use it to predict y for values of x that fall within the range of that original data set that was given to you. So if they said here that the lowest on-base percentage was 0.31, highest on-base percentage was 0.362. And then when x is 0, 0 is not in between. 0 is less than 0.310. It is less than that. So it is not in between the data set. So no, it does not make sense to interpret y-intercept. It does not. C, would it be a good idea to use this model to predict the winning percentage of a team whose on-base percentage was 0.250? Again, 0.250 is less than, it's not in between. Okay, you use the least squares regression equation to predict your y for those x values that are in between the data set for the x. So 0.250 is less than 0.310. So when x is 0.250, no, it's a bad idea to do that. Okay. D, a certain team had an on-base percentage of 0.326 and a winning percentage of 0.544. What is the residual for that team? How would you interpret this residual? So I'm going to pull up my calculator. Just click reset here. Let's type in the least squares regression equation. That is 2.94x minus, please put your minus here, okay? Minus 0.4877. And in this case, for D part, x is 0.326, which is the on-base percentage, and y is 0.544. Calculate. So the residual to 4 decimal places would be 0.073 3. Okay, that's the residual. And this means that the given y is above average for teams with the given x. So the residual indicates that the winning percentage of the team A is not it. B, it indicates that the winning percentage of the team is above average for teams with unbased percentage of that given x. Okay, that is B. Remember, you have to look at the options very well. Okay, and that is B. Question 10. Question 10. Because colas tend to replace healthier beverages, and colas contain caffeine and phosphoric acid, researchers wanted to know whether consumption of cola is associated with lower bone mineral density in women. The data shown in the accompanying table represent the typical number of cans of soda consumed in a week and the bone mineral density of the femoral neck for a sample of 15 women. The data were collected through a prospective cohort study. Complete parts A through F. Find the least squares regression line, treating cola consumption per week as the explanatory variable. So this is the table here, which I need. And I'm going to pull up my calculator. We can use the first formula or second formula, it doesn't matter. But let me reset this. Okay, so 0, 0, 1, 1, 2, 2, 3, 3, 4, 5, 5, 5, 6, 7, 7, 8, 0, 0, 1, 1, 2, 2, 3, 3, 4, 5, 5, 6, 7, 7, 8. Then your y, you have 0 0.893, 0 0.882, 0 0.891, 0 0.881, 0 0.888, 0 0.871, 0 0.868, 0 0.876, 0 0.873, 0 0.875, 0 0.871, 871, 0 0.867, 0 0.862, 0 0.872, 0 0.865. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3. You see I missed the 0 here. So you could use your and it still does, I mean it still wouldn't matter, but you could use your cursor to go through everything to make sure it is correct. 0 0.893, or you could also use Statcrunch to do this. Okay, I did Statcrunch in that Module 4 homework study guide video for finite math. Okay, 0 0.893, 0 0.882, 0.8913, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Calculate. So the least squares regression line is negative 0.0029 x plus 0.8861. They rounded to 4 decimal places. So if you look at it, the answer would be D. Okay. Interpret the slope. The slope means that for each additional cola consumed per week, bone mineral density will decrease. The slope is negative. Okay. Decrease by 0.0029 on average. Interpret the intercept. Intercept is when x is 0. So for a woman who does not drink cola, bone mineral density will be 0.0029. No, it will be 0.8861. Okay, because when x is 0, that is when you find your y-intercept. So the correct option is C. Okay, I think I hit this twice. I hit my keyboard twice. Can you imagine that? So the correct option is C. Okay. D, predict the bone mineral density of the femoral neck of a woman who consumes 4 colas per week. Let's go ahead and predict this. So we need the least squares regression line, and that is, if you scroll down here, predicted y. So what I'm going to do, I know probably they used the rounded value, but I'm not going to use the rounded value. I'm going to use and if you use the rounded value, that's fine, but I'm going to use the actual value. So I'm going to copy this, copy. I didn't copy everything. I copy this whole thing here, copy, and I come here, predicted y, and I paste this here, Control V, or right click and paste. That's the slope, and then the y-intercept. And if you like, you can use the rounded value, because I think that is what they used. Okay, you're still gonna round to 4 decimal places. Usually I suggest you use like 6 decimal places for intermediate calculations. You know, it's advisable. Because the final answer for this is 4 decimal places, then make your intermediate calculations to at least 6 decimal places. So I suggest to at least 6 decimal places. So I suggest you don't use the rounded value, because if you use this rounded value, you might mess up. You might get it wrong, or you might get it right. I don't know. You know, but if you get it right, that means you're lucky. You're probably not supposed to get it right if you use rounded values, because they used it 4 decimal places. Now, with 4 colas per week, the difference might not be much. Okay, but just as an advice, if the final answer, or if the answer they're asking you, if they ask you to round your answer to 4 decimal places, that means round the intermediate calculations to at least 6 decimal places. Okay, that way you're very sure of the answer. So this is the least squares regression line right here, and our x is 4 colas per week. And I know they didn't give us the y. That's fine. Don't put, if you click calculate, they want you to put something here, that's fine. Just put 0, it doesn't matter. Okay. Or you can just do it with your own calculator. You know, use the least squares regression line, multiply x by 4, and then you can get your predicted y. So here the predicted y is to 4 decimal places will be 0.8745. Okay, that's it. The researchers found a woman who consumed 4 colas per week to have a bone mineral density of 0.873 grams per centimeter squared. Is this woman's bone mineral density above or below average among all women who consume 4 colas per week? So, for 4 colas per week, you see the predicted y is 0.874. Okay, that's the predicted y. But the woman had 0.873. Please don't look at this residual for now. Don't look at the residual. We are still unpredicted. Okay, so for somebody who consumes 4 colas per week, the person is supposed to have a bone mineral density of 0.8745. Okay, 0.875 if you round to 3 decimal places. Grams per centimeter squared. That is the predicted y, this right here. That is what we should be looking at. However, this woman consumed 4 colas per week and has 0.873 rather than 0.875. So that means that this woman's bone mineral density is below average than what she should have had. Okay. Would you recommend using the model found in Part A to predict the bone mineral density of a woman who consumes 2 cans of cola per day? Let's look at this question again. This question says cans of soda consumed per week. Okay, cans of soda consumed per week. So all these are no can of soda per week, 1 can of soda per week, 2 cans of soda, 4 cans of soda, 8 cans of soda. So the original data set is between 0 and 8. And then here, they gave us 2 cans of cola per day. Okay, 2 cans of soda cola or cola soda per day. So 2 cans of cola per day means how many per week? That would be 14 cans per week. And 14 cans is outside is greater than 8. So because of that, I will not use this model to do that, to predict that. No. Question 11, you can look at this later on. The given data represent the total compensation for 10 randomly selected CEOs and their company stock performance in 2009. Analysis of this data reveals a correlation coefficient of R is negative 0.2120. What would be the predicted stock return for a company whose CEO made $15 million? What would be the predicted stock return for a company whose CEO made $25 million? Let's go ahead and remember, for us to get predicted Y, there has to be a relationship. Once there is a relationship between the variables, then we find the least squares regression equation. Then we can now find the predicted Y. So let's first of all find they gave us the correlation coefficient, but let's see whether there's a relationship. So let's solve this. Let's solve this question. We can use first or second formula, it doesn't matter. Let me use the second formula since I just used the first. So reset this. Type in for x 26.43, 12.08, 19.84, 13.42, 12.31, 11.92, 26.33, 15.25, 17.87, 14.48. For y, 5.67, 30.41, 31.64, 80.02, negative 8.44, 2.91, 4.67, 10.36, 4.28, 12.01. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Calculate. So this reveals a correlation coefficient of negative 0.2120. Okay. I see that some things are still part of, some results are still part of what we had before. So I'm just going to close this and open it back up. As you can see here, yeah. So later I can fix this problem, but because some things, if you can see, some things are still, no relation exists between the variables. So there shouldn't be least squares regression line, there should not. So this was what, because of the former question. Okay, so I'm just gonna close this now, or I can refresh it actually. Let's see. If I refresh the browser, there you go. Oh, refreshing the browser didn't work. Okay, refreshing the browser worked. It worked. Let me just reset. Before I reset it, let me look at it. Okay, so I just refreshed the browser and my data is still the same. Now I can click calculate. There you go. I can click calculate. Okay, so the correlation coefficient is negative 0.2120. So this is negative 0.2120. So they actually got it right for this particular data. Okay, but there is no relation that exists between the variables. There is none. Now, so when a relation does not exist between the variables, excuse me, and they ask you for the predicted y, because if a relation does not exist between the variables, you cannot find the regression equation. You cannot. So when they ask you for the predicted y, you just use the sample mean for y. So just for the y values here, just add it up and divide by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what you just use the sample mean as the predicted y for any x. For any x. So the answer here would be, to one decimal place would be 17.4. 17.4. Okay. And even for 25 million, for any x, use the same predicted y. 17.4. Okay. Question 12. Question 12. Analyze the residual plot below and identify which, if any, of the conditions for an adequate linear model is not met. So, as you can see, this is your residual is like curved. Okay. Plot of the residuals on the y against the explanatory on the x. So if it's curved like this, we call it pattern residuals. Okay. Question 13. The following data represent the time between eruptions and the length of eruption for 8 randomly selected geyser eruptions. So time between eruptions is your x. Length of eruption is your y. A. Does the residual plot confirm that the relation between time between eruptions and length of eruption is linear? So let's click here to view a residual plot of the data. So you look at this residual plot of the data, okay? You see there's no discernible pattern, and because of that, a linear model is appropriate. Okay, so we'll say yes, the plot shows no discernible pattern. A linear model is appropriate. B. Then the coefficient of determination is found to be 92.7%. Choose the best interpretation below. With the coefficient of determination giving us 92.7%, this means that the least squares regression equation explains 92.7% of the variation in length for the y. Remember, does that for the y, variation in length, not variation in time, but variation in length of eruption. So it explains, excuse me, it explains 92.7% of the variation in length of eruption. Question 14, last but not the least. Later you can view the instructor tip. The time it takes for a planet to complete its orbit around a particular star is called the planet's sidereal year. The sidereal year of a planet is related to the distance the planet is from the star. The accompanying data show the distances of the planets from a particular star and their sidereal years. Complete parts A through E. Draw a scatter diagram of the data. So let's click on the table, open in Statcrunch. Graph, Scatterplot. X variable is distance from the star, X. Please don't select planet, please. Okay. Distance from the star, X, in millions of miles. Y variable is the sidereal year. And then you click compute. So let's look at this, and you can close this and compare. So which one looks like this? If we look at this, we'll see that A is eliminated, C is eliminated. So looks like B, scatter diagram. Okay. B, determine the correlation between distance and sidereal year. Okay, I'm gonna get my calculator. And I need this table. So like we just did, just refresh this. Okay, go ahead and refresh it. Refresh it and then reset. You can reset. Okay, you can reset, refresh and reset. And refresh will remove the answers, the previous answers, and reset will remove the questions. See that? You have a, yeah, so refresh and reset. refresh, and reset. Refresh and reset. Okay, we can use first or second formula, it doesn't matter. I think we used, I don't even know which formula we used last. Okay, let's use the first formula here. We have 36, 67, 93, 142, 483, 887, 1785. Please don't put don't put 1,785. No, just write it as is: 1785, 2797, 3675. And then your y will be 0.22, 0.62, 1.00, 1.86, 11.9, 29.5, 84.0, 163.0, 245.0. And we click calculate. Okay. So the correlation between distance and side view here is to 3 decimal places will be 0.989. 0.989. Okay. Does this imply a linear relation? Of course, there is a positive linear relation. Yes. Yeah. There you go. Yeah. Compute the least squares regression line, and that is right here. 0.0649 x plus negative. So plus minus is minus. Okay, plus minus is minus. So 0.0649 x minus 12.216. That is this option. Okay. Plot the residuals against the star. Plot the residuals against the distance from the star. Choose the correct graph below. Okay, so to plot these residuals, these are the residuals right here. These are the residuals right here. Okay. So what we're gonna do now is we will open up Statcrunch. Well, don't open up Statcrunch. Let's get back to the table and open Statcrunch from there. Open a Statcrunch. And we are going to, let's see here. We are going to rename this variable to residuals. Rename it to residuals, and let's put this in 2 decimal places. Okay, these are the residuals here. Observed y minus predicted y. So we have 10.10 because it's 10.098. So 10.10, 8.49, 7.18. So just be careful here because the commas, okay, the commas indicate the new one at the end of after the commas. Then you have 4.86, 4.86, and then after the next comma you have negative 7.25. Then you have another negative 15.88. Then you have negative 19.69. Okay, negative 19.69. Then you have negative 6.397, so 6.40, right? And then you have 18.59. So this is what you have here. 18.59. Yeah. So this is the residual that I used here, the residuals. And you can now plot this. Graph, Scatterplot. Our x will still be our x, but our residuals will now be our y. Our y will now be the residuals, and you compute. So look at the graph here, the residual plots right here, and you can compare the residual plots. So which one looks like that? A is eliminated, B is eliminated, looks like C, option C. There you go. Okay. Do you think the least squares regression line is a good model? It is not. It is not, because look at these residuals, the way it's patterned. So it's not. No, it's not. Okay. And that is it, right? That is it. And you click save, 100%. Yeah, you click save. All right. Thank you so much for listening to this video session. If you have any questions, please ask. And you have a good night.